All right, hey everybody. Today we are going to be looking at LOL charts in relation to energy. We've got a cart loaded on a spring that's being shot on a loop-de-loop. So we've got two bar charts and a circle in the middle for the O that represents our system, so everything that's in our system. So the first thing that we've got to do is we've got to read our problem. So in the situation shown below, a spring launches a roller coaster cart from rest on a frictionless track into a vertical loop. Assume the system consists of the cart, the earth, the track, and the spring. So first thing we've got to do is list all the things that are in our system, okay, into our system on our on our sheet. So you've got to write for that first part, for A, you've got to write that the cart, the earth, the track, and the spring are all part of our system, okay? Then, since we don't have any numbers here, and this is going to upset some of you guys, like students usually get a little frustrated here, you've got to pick qualitatively how many, we're going to call them bars, that you want to use for all of the problems in this set, okay? That might sound a little confusing, but you're going to see what I mean when we go through it. So you can see for part A, okay, the cart is loaded onto a spring, okay? So you're going to know that there's going to be spring energy, okay? It is, let's say it's at like the lowest point of our system. So even though there is still gravitational energy, since it's on like the ground, okay, we're going to say that there's no EG in this account, okay? And it's also not moving, so there can't be EK. So everything for this first part for A is going to be loaded onto the spring, okay? So I'm going to choose a number 5, just because 5 is a flexible number for us to work with, and you're going to see what I mean as time goes on. So I'm going to do this 1, 2, 3, 4, 5, okay? So everything is loaded into ES, okay? Then the cart gets shot, okay, and it goes around the loop-de-loop, and it's up here at the top of the loop-de-loop for B. So for B, if I'm looking at it, if I look at my first account, EK, it is moving, so there is some EK, okay? EG, there is some height compared to where I started, so there's going to be some EG. ES, it is no longer loaded onto the spring. The spring is no longer transferring energy to the cart. So there's going to be no ES, and it says that it is frictionless, okay? So there's going to be no ETH in the interaction between the cart and the track, okay? So everything has got to go from the spring, okay, into EG and EK. So we've got 5, all right? Now, what I'm going to say is, like, there are multiple correct answers here. But I'm going to show you the way I interpreted the question. So as it gets to the top of the loop-de-loop, okay, it's slowing down a little bit. It's not going as fast as it was down here. Okay, so I'm going to put, since it's not all transferred into EK, I'm going to put this as 3. Okay, so it's going to be 1, 2, 3. And then EG, I'm going to put as 2. Okay. Once again, since we don't have numbers, we don't know exactly what the transfer is going to be, but we do know that some of the energy is going into EK, some of the energy is going into EG. And we also see that energy is conserved because there's 1, 2, 3, 4, 5 units of energy and 1, 2, 3, 4, 5 units of energy on the second part. There's nothing in spring energy because there's no spring, and there's no heat or thermal energy because there's no friction. So what our equation would look like, okay, for our qualitative energy conservation equation, what that's going to look like is that's going to be ES equals EK plus EG. Boom. Now, for the second part, okay, for B, it says repeat problem 1A for a frictionless system that includes the cart, the earth, and the track, okay? So there's no spring in this. So our equation does not have spring, but the conditions are exactly the same for 1B as they were for 1A, okay? But since there's no spring in our system, we're not gonna have anything over here, okay? There's also no EG because there's no height and there's no EK. So what we've got to do, and since the conditions are exactly the same, we got to do the exact same thing for the second part of our LOL as we had for our first equation, but all of the energy is coming into our system, or transferring into our system from the spring. Since it's out of our system, it's coming from outside, and the way I like to do it is 1, 2, 3, 4, 5, okay? Some people like to do tick marks, but that indicates that 5 units of energy are coming into our system, okay? For C, it says, use the same system as problem 1A, but assume there is friction, okay? So everything has to start with ES again, because the cart is back into our system. So it's the same as 1A, but the cart is back in our system. But now there's friction, okay? So friction, I know, typically slows things down. So I want you guys to think at home, like, what energy account on this back end is friction going to take away from? So if it's slowing something down, you can pause it and think about it for a second. If it's slowing something down, I'm going to take it from EK, okay? Because the height at the top of the loop-de-loop is still the same. So EG, I'm going to make 2, because the gravitational energy is the same because it's the same exact height. But now instead of EK being at 3, since there's friction and it's slowing it down, I'm going to put that at 2, okay? And then I'm going to have 1 as ETH. Now, the way you could have interpreted it, you could have put EK at 1 and ETH at 2, because it doesn't tell you anything about the coefficient of friction or how much friction there is. It just says there is friction. So that is where you've got some wiggle room, but you've got to be able to show that since there is now friction, it's being taken from EK and being put into ETH, okay? Now for our last part, part D, situation is the same as 1A, except that the final position of the cart is lower on the track. So make sure your bars are scaled consistently between 1A and 1D. Assume that the system consists of the cart, the earth, the track, and the spring, okay? So it says the conditions are the same as 1A, and 1A was frictionless, okay? So let's look up at that again. So we're gonna do our, oops, this was supposed to be 5. I apologize, guys. Hopefully you guys did catch me there. This needs to be 5 down here, okay? 1, 2, 3, 4, 5, okay? And it's just not getting as high. So you guys should think, okay, well, since it's not getting as high, it should be going a little bit faster than it was before, okay? Since it's not slowing down as it's going up, but it's also going to have less gravitational energy. So what we're going to do, and since there's no friction because it's the same as A, we're going to take one from EG, okay, and put it into EK. So this would be 4, yeah? 1, 2, 3, 4. And this is going to be 1, okay? So if you were to look at this, everything's going from ES into EK and EG, just as it was in 1, except it's not getting as high, so there's not going to be as much EG, and there will be more EK because it will be going faster. So just for those of you playing at home, I know this is a new concept, and we're purposely taking some of the vocabulary out of it so you can grasp it conceptually. But what you're going to be looking at is if there is a velocity, if it's moving, you're going to have EK. If there's a height, okay, you're going to have EG. If there's a spring, a loaded spring, you're going to have ES. And if there's friction on the back end of your LOL chart, okay, you're going to have ETH, or thermal energy. Okay, if you guys have any questions about this, please make sure you email one of us, and that will be it for today.